Hello students, we are going to start organic chemistry of BSc Part 1, and before starting of the chapter number 1, we are just going to learn some basic topics of organic chemistry. So let us start the basic chemistry of organic chemistry with the topic isomerism. You have, I think, heard about this topic in your lower classes. Let us take up a look of isomerism. What we are going to learn here, we are going to discuss the type of isomerism, structural isomerism, stereoisomerism, and one of the type of stereoisomerism, that is geometrical isomerism. So what is isomerism? Isomers basically are those molecules which have same molecular formula but different physical and chemical properties. So we can take example of this molecular formula, that is C2H6O. Here one is ethanol and another is dimethyl ether. These two have the same molecular formula, and we can clearly see the difference in their boiling points. So these two have the same molecular formula C2H6O, but they have different physical properties, so they are isomers of each other. Now, type of isomerism, two main types are there. One is structural isomerism, that is also known as constitutional isomerism, and another is stereoisomerism. So the first one is structural isomerism. Isomers which have different molecular structure. Different molecular structure also indicates about different bonding arrangement. It means different atomic connectivity. All these things are same. Different bonding arrangement or different atomic connectivity results in the different structure. Yes, this simple chart showing the type of stereoisomerism and type of structural isomerism. Now, the examples of structural or constitutional isomerism. Two examples are there. The first one example we have discussed as the examples of while discussing, we were discussing the definition of isomers, and this is another example of propene and cyclopropane. These two have same molecular formula, that is C3H6, but we know that this is alkene and this is alkane. So there is so many differences in their chemical and physical properties. So these two have same molecular formula but different bonding pattern, different atomic connectivity that results in the different structural formula. This is known as structural isomerism. We can see that the same number of, in the first example, same number of carbon, it is 2, same number of hydrogen, it is 6, and same number of oxygen, it is 1. But we can see that there is a sufficient difference in the bonding pattern. Like in the ethanol, one oxygen is bonded with carbon in one side, and on the another side it is bonded with the hydrogen. While in dimethyl ether, the oxygen atom is bonded with carbon atom on both the sides. So this is the difference between their atomic connectivity, bonding pattern, and that results in the difference of physical and chemical properties. And that is the meaning of constitutional isomerism. Likewise, we can discuss this example. Both these two compounds having 3 carbon and 6 hydrogen atoms, but because of the difference in their atomic connectivity, they have sufficient difference in their physical and chemical properties. So the perfect example of constitutional or structural isomerism. Now, the second type of stereoisomerism is isomerism is stereoisomerism. Stereoisomerism is basically related to the different arrangement of atoms or groups in space. It means two stereoisomers, they have same molecular formula. They also have same structural formula. It means they have same bonding pattern, But what is the difference between the stereoisomers? They have different spatial arrangement of their atoms or groups. So as an example, we can take the 2-butene. 2-butene, it has it is an alkene, and on both the carbon, two hydrogen on both the carbon and two methyl groups are attached. But we can clearly see the difference in these two, cis and trans butene. In the cis, these two hydrogens are attached on the same side of double bond, and in the trans form, they are attached on the opposite side of the double bond. That is why there is a difference in spatial arrangement, and that is why there is a difference in their physical properties. It reflects in their boiling point, in their dipole moment. So that is why these are the perfect pair that make us enable to understand the meaning of stereoisomerism, because there is a difference in the position of hydrogen and methyl groups in space. Yes, now structural isomerism, some types are there, three main types are there. Chain isomerism is there, when we are going to discuss all these three in the next slide. Yes, chain isomerism. Chain isomerism means the same molecular formula but different carbon skeleton. We can see in this example, there are two examples of butene, and in one example there is a straight carbon chain, and another one there is a branch of methyl group. So there is a huge difference in their boiling points. So that is why these two are chain structural isomer, because they have difference in their carbon skeleton chain. Positional isomerism, it means they have the different functional group of different position of their functional group, like pent-1-ene and pent-2-ene. Double bond is between carbon 1 and 2, and double bond is between carbon 2 and 3. Yes, so this is the example of positional structural isomerism. Functional group isomerism, we can clearly understand the meaning of functional group isomerism. They have same molecular formula and same molecular formula, but different functional group is there. Like in alcohol and ether, same molecular formula of these two. We have also seen one example in the introduction of this topic. Because of these two different functional group, alcohol and ether, these have sufficient difference in their chemical and physical properties. Likewise, we can discuss the example of aldehyde and ketone and acids and esters. These two also have also shows functional group isomerism. Yes, now stereoisomerism, we have discussed the meaning of stereoisomerism. It denotes the different spatial arrangement in that three-dimensional space. Two main types are there, geometrical and optical isomerism. Basically, the two types of stereoisomerism are configurational and conformational, and under the configurational, these two are there. So the conformational we will discuss in the separate unit. Now we can understand the meaning of the geometrical isomerism with the example of alkenes. Alkenes have one double bond, and because of the double bond, there is a phenomena of restricted rotation, and because of this restricted rotation, the two arrangements are there. We have also seen in the introduction of stereoisomerism. These two green balls represent the methyl groups. These are in same side in the cis, and when methyl groups, or we can say the hydrogen atoms, are on opposite side, they have the compound is trans and cis. Yes, through this animation we can see there is a rotation, free rotation, when there is a single bond between two carbon atoms. So, and when there is a double bond, there is a restricted rotation. Here we can understand there is a restricted rotation. The compound cannot perform the free rotation. That is why two positions are there, which are cis and trans. So in the geometrical, we can clearly understand that in these two situations, geometrical isomers are not possible. So what is the geometrical, what is the essential condition for a molecule to show geometrical isomerism? It is that there should not be same group attached on the same carbon. In these two same groups are attached on this carbon, and in this example also, these two methyl groups are attached on the same carbon. So such compounds, they do not show geometrical isomerism, and the remaining two, when the different groups are attached on the carbon atom, this shows the geometrical isomerism. So by this analogy, we can clearly understand that out of 4 possible isomers of butene, only the two are stereoisomer of each other, and 2-methyl propene and butadiene, these two are also isomer of 2-butene, but these doesn't show stereoisomerism. Thank you once again.